I can't really tell the difference between this and if we were communicating regularly through the GoToMeeting thing. All right. Let's do some more algebra. We might have done this one, but that's okay. Factor this fully. It's the first.
Just x squared.
So x squared is the greatest common factor. We're going to pull it out, leaving
X squared minus x.
Now hold on. Now check your work. See if that's right. Is it?
I don't think so.
No, because x squared times x is x to the cubed. So this can't be x. What must it be?
1.
Right. Okay, now factor it more. What's this called? When I say this, I mean that has a name. And it's good to learn the name, because when you learn the name, you'll learn to recognize what it is. It's called difference of what? Difference of perfect squares.
Okay.
Is what that is called. Why? Because that's a perfect square and 1 is a perfect square. A lot of people don't recognize 1 when they see it. So how does that factor? X squared minus 1.
Don't you do x squared plus 1?
No, it's x minus 1 times x plus 1.
Oh, yeah.
In other words, whenever I have a squared minus b squared, that's the difference of perfect squares, it's always a minus b times a plus b. And that's when you that's the only way to do difference of perfect squares. There's no way to factor it in any of the other methods that we've been working on.
Okay.
So let's try an easy one. This one's out of my book, but it's along the same style as what we've been doing for the last 2 sessions. Step 1.
Put the x squared on the outside?
No. That would be a greatest common factor. If there was a greatest common factor here, I would factor it out. But notice there isn't. There is no term that divides evenly into each of these 3 terms. This is a standard quadratic expression. It's got the x squared, it's got the x, and it's got the constant. So when you see quadratics like this, know that you have to factor them with the double set of parentheses, as opposed to greatest common factor, as opposed to difference of perfect squares. There's lots of things involved in factoring. You got to learn all of them. You got to be able to get to a point where you can factor. So what's the first step in factoring this?
Put x squared in each box and each parentheses.
All right. If I do that, now before you take the next step, is that going to work? Remember, just x, exactly. In other words, the moment you make this mistake, you should recognize it, because x squared times x squared would be x to the 4th, and it's not x to the 4th. So it can't be x squared and x squared. In other words, your very first step should be to multiply these 2 back together again and make sure you get what you started with. Second step in factoring this quadratic.
Put a plus minus?
Well, what must the signs be based on that? The same or different?
The same.
Well, that's correct. They have to be the same. It's the only way you can produce a plus, is if the signs are the same. So we know it's either minus minus or plus plus. How do we tell which it is?
From the sign in front of the book?
Yeah, from the sign on the middle term. In other words, these two signs are very important. They tell you everything you need to know in terms of what the signs are going to be down here. This tells you they both have to be the same. This tells you they both have to be negative. Third step.
Find factors of 9 that can add to negative.
Not negative 6. Just 6.
6.
Okay? And those factors are 3 and 3.
Yeah.
When you say add to negative 6, it just kind of confuses the issue. In fact, you're right. They do have to add to negative 6. But there's no need to incorporate this when you're doing that last step. They have to add to the number 6. I've already taken care of the negative sign when I put negative negative down here.
Okay.
Okay, how about this one?
Put X in each parenthesis. And put a plus in each of them. And then find factors of 25 that add to 10.
What are those?
5 and 5.
Recognize that as a perfect square number. And when you're looking for factors that have to add or subtract to this number, usually a good place to start is by looking the factors that are closest together. In other words, we have 25 and 1, and we have 5 and 5. Well, I'm never going to start there. I'm always going to start with factors that are close together. In other words, if my number is 12, I'm going to start with 4 and 3. I'm not going to start with 6 and 2 when I start experimenting.
Okay.
Here's one that's a little different. Let's see if you can figure this one out. Now, no, they wouldn't be giving you this problem if it didn't have a nice, tidy solution. So let's go through all 3 steps. First step.
X.
Second step.
Addition. Plus.
Plus plus. Third step. Factors of 1/4 that add to what?
X. 1.
1, not X, 1. So think about factors of 1/4. We're not used to factoring fractions. Well, there's one factor. Now do our little technique. What's another factor? Double this one and halve that one.
So 1/8 and 2.
When you have double this one and halve this one, not the other way around.
Half.
There you go. I doubled 1/4, which means I have to take half of 1. Well, those are your two factors. 1/2 times 1/2 is 1/4. So they are factors of 1/4, and they do add to the number 1. So the answer is x plus 1/2, x plus 1/2. All right. Go on. I'm going to introduce you to what I call level 2 factoring. And it's not because this is a 2, it's because it's some number different than 1. In other words, whenever you have a number in front of the x squared that's not 1, it's what I call level 2 factoring. Now, let's make it easy here. First of all, first step is still the same, which is to split up the 2x squared. What can I put here and here that multiply together to make 2x squared?
1x.
Well, there's 1. What needs to go here?
X squared.
Well, multiply those together. What would it be?
No, that's not right.
Okay, because that would be x cubed, right?
Yeah.
Okay, so we need to find something here. The easy way to do this is to take this and divide it by x. What do you get? In other words,
Divide 2.
yeah, take that and divide it by the thing you've already taken out, x. What do you get?
2 squared.
Okay, when you divide 2x squared by x, there's a 1 right there, and you subtract the exponents. So that is equal to 2x. That's what goes there. A little experimentation, you would have known or figured out that we have to, if that's x, that's got to be 2x. Because now when I multiply them back together again, I get 2x squared. That's the key. Okay? So the first step is basically the same. It's to separate those things. Had that been a 3x squared, then it would be x times 3x. Had that been a 4x squared, then I got some choices. We'll get to that in a second. But in this one here, it can only be x and 2x. There's no other choices.
Mm-hmm.
Second step is similar. Figure out both signs.
Both signs.
Both signs. Same second step as before. What are they?
Plus and plus.
Uh-huh. Third step. Almost the same. Factors of 5. But here's where you have to change it. You can no longer say factors of 5 that add to 11. That's not the case anymore. And in fact, there's nothing you can say. What you can say is the only thing we know about these two numbers is they have to multiply to 5. Well, how many factors of 5 are there? Just 1. One set. So my answer is either 1 and 5 or 5 and 1. Which one produces the correct middle term? In other words, we're no longer, we know we have the correct term there. We know that as long as we put in 1 and 5, we're going to have the correct term there. So at this point, it's trial and error as to whether or not we produce the middle term. So let's just try. There's 1, there's 5. What middle term does that produce?
6.
Remember, you get the middle term by multiplying the inside and the outside. Multiply the inside, what do you get?
3x.
No. Remember?
2x.
Yes. Any number times 1 is that number. So it's plus 2x. And I put the sign on there intentionally. What do you get when you multiply the outside?
5x.
Add them together, that's your middle term. Is that the middle term? Is that the middle term we're looking for?
No.
Okay, so that's wrong. So our only other choice is to put the 5 here and the 1 over there. What middle term does that produce?
11x.
That's our answer. Okay, so
11x.
yeah, in other words, that's the correct factoring because that's plus 10x. That's plus 1x. Add those two together, you got plus 11x. That's our middle term, so we factored it properly. This is a process you should do every single time that you're factoring, is this final process of checking the middle term. Like I said, you don't need to worry, you don't need to completely foil these two things together. In other words, you don't need to reproduce this entire thing. You just need to check the middle term. Now, let me think for a moment. Slightly harder to factor this. It's still a level 2. I call anything that's not level 1 level 2. And that means that anything that doesn't have a 1 in front of the x squared is level 2. It's going to be a little bit harder. First step.
What 2x in parentheses?
Well, if I did that, what would I have as a first term? What do you get when you multiply that by that?
Oh, 4x.
Ah, that's not right then. You get 4x squared. How about that? Same thing we had.
So, yeah.
Same thing we just had. In other words, there's no difference on the first step. Second step. This is where it starts to get a little tricky on these level 2 quadratics.
Put 2 negatives then?
2 negatives would produce a positive. How can you produce this number?
Oh, put a positive and negative?
A plus and a minus. In other words, the signs have to be opposite. Notice the first time you see this negative 5, you know these signs got to be different. But here's the catch. This plus minus is not necessarily going to be the same as minus plus, because the plus is multiplying this term, the minus is multiplying this term. So in level 1 quadratics, it doesn't matter. It's plus minus or minus plus, and both are the same. There's no difference. Here, there's going to be a difference. In other words, it might be minus plus. So this is the way I do it. I don't know if this is the way your class is going to do it or not, but I find this is the best way to do it. All right.
Okay.
Now, still looking for factors of 5. Well, those are the only 2 factors. So I basically have 4 choices. I can put a 5 and a 1. That's my first choice, and see if that works. I can do a 1 and a 5. That's my second choice. See if that works. I have 2 other choices. I can put the 5 there and the 1 there, or I can put the 1 there and the 5 there. So actually I have 4 equal choices to try. However, I'm going to give you a little bit of clue as to why one works and the other doesn't. Let's start out with this one. What does that produce as a middle term? Now understand how I'm writing this. In other words, this left one would be 2x minus 1, the right one would be x plus 5. Again, I don't have to check this end term. I don't have to check the beginning term. I've already checked those. Let's check the middle term. What gets produced there? What gets produced on the outside? What's the inside multiply to be?
Negative 1x.
What's the outside multiply to be?
7x.
No. What's 5 plus 5 times 2x?
20x.
No, multiply the two numbers, 10x. In other words, you're still getting a little confused with between multiplication and addition. Very, very important that you learn to distinguish those, because they're not at all the same. Okay? So, now I have to add those two. What do I get when I add those two? What's minus 1x plus 10x?
Yes.
Plus 9x. Okay.
Yes.
Now, notice that that's the right number, but the wrong sign. That's huge. That means I know my answer is instant if I just change the position of this. In other words, I take this 1 and move it up to the other sign like that, and I move the 5 up to the other sign like that. Now, when I multiply the insides together, I get plus 1x. When I multiply the outsides together, I get minus 10x. And adding those two gives me minus 9x. That's my correct middle term. I have found my solution. Erase that, erase all of that. Now I know that's my solution to factoring this. Now, that trial and error process is very helpful because it means I don't ever have to try all four. In other words, when I originally thought I have to try all four combinations, I really don't. I just have to try one. Now, let's assume that the one that I tried was this one. That's my first one. What does that produce as a middle term? See if you can do it in your head without me drawing my two smiley faces.
Okay. Wait. 5x and x plus 1x.
First of all, minus 1 times 2x is minus 2x.
So minus 2x plus 5.
Okay. What does that give you?
3x.
Right. That's not even the right number, let alone the right sign. The fact that it's not the right number means there's no point in trying the 5 down there or the 1 down there, because that'll give me the same numbers I just got, only the different sign. So this first attempt tells me that I don't even have to try the 5 down here and the 1 over there. So the only thing I need to try next is just to switch the numbers. Put the 1 there and the 5 there. That's my answer. That's my answer with only 2 tries. So it's a trial and error process for sure, but it's not one that you can't reduce drastically.
Okay.
Look at this one for a moment. Let's make it a little harder. All right. We'll do this one and we'll be done for today.
Okay.
What's the start?
Put X in one and then 7.
X in one, and what in the other?
2X.
Okay. What are the signs?
Plus.
They're opposite. That should be your answer. They're opposite. They're either opposite or the same. That's what you want to look for with the signs. Are the signs the same or if they're the opposite? If they're the same, then I don't have any problems. But if they are the opposite, I have to allow for both of these, like this. You always have to allow for both if this coefficient is not the same as this coefficient. 2 is not the same as 1, so I have to allow for plus minus or minus plus. Third step.
Find factors of 12.
Okay, list all the factors of 12 for me.
6 and 2. 3 and 4.
That's it.
Is that it?
Uh-huh. So we know we need these two numbers, but where should we start? We got a lot of trial and error things here. In other words, it's not as easy as it was when we had 5 and 1. When you have 5 and 1, there's only one choice, 5 and 1. But now we got all these choices. Always start with the two factors that are closest together. Merely because that's the kind of problems they give students. They don't give students the problems where the factors are 6 and 2 or even 12 and 1. Not very often. Sometimes, but not very often. Mainly when it's a trial and error process and you're looking to begin somewhere, well, pick the two closest together. Okay? And I'm just going to randomly start there. And I do mean randomly. I'm not looking at the problem at all. I'm just plugging those in. What does that give you as a middle term?
Hold on. So 5x.
Hold on, where are you getting 5x? 3 times 2x is 6x.
6x plus negative 4x.
Okay, what's that?
2x.
Okay, wrong number, right? We're looking for a 5. Whether it's plus or minus doesn't matter. If it's not a 5, then this is not correct. What's my next step? I can rule out this option. What other option does that also rule out?
4 and 3.
Right. In other words, no. It rules out having the 3 with the negative sign and the 4 with the positive sign. Because that's going to produce that same number we just got, which was a 2, not a 5. So I don't need to try 3 here and 4 there. But I do not need to try switching them. 4 here and 3 there. What number does that produce as a middle term?
$3x.
No. What's the inside?
So 8x.
And what's the outside?
Negative 3x.
And add them together.
5x.
That's it. And that's how you do these level 2 quadratics. It's not that much harder. It's not that much harder, it's just that you can't use those rules like factors of 12 that subtract to the number 5, or, you got to throw that part out. You just got to basically find your factors and start trying them one by one. Okay? We'll get you good at this. And when you're good at this, you're good at algebra. Let me clue you in. That if we can get you good at factoring quadratics, taking the greatest common factor, factoring it when there is no greatest common factor, and factoring it when it's the difference of perfect squares, you'll be miles ahead of everybody else. And that's going to help you a lot, okay? But the one thing you got to really pay attention to is whether you're multiplying or adding. You tend to get them confused. In other words, 2 times 3x is 6x, not 5x. 2x plus 3x would be 5x. But that's addition, not multiplication. So, all right.
Yeah.
Jenna, I will speak with you on Monday at 9:30. We'll do more of this.
Okay.
All right. Bye-bye.